Tony, my friend.
Hey, what's up, Jordan?
How you doing?
I'm hot. How are you?
Yeah, you're hot. Yes. So Lakshmi, you saw this, you answered it. So Lakshmi just in the chat asked what we're talking about tonight. So there's a couple of things that we're talking about tonight. But the reality is that there's no agenda for tonight. So typically we have at least a rough outline, the things we want to talk about, some sort of plan, just because, that's probably the right way to go about this. But it's been yet another crazy week. It's been, I was telling Tony, I just finished work an hour ago. And so there was no prepping for this one. So what are we talking about tonight? Well, whatever comes up. So I'm super interested for those who are watching in real time. If you've got something you want to chat about, throw it in the chat. If you're really brave, I might invite you on. Come talk with us because we can talk about whatever. Tony and I filling 2 hours of conversation about networking stuff's no problem at all. We're both seasoned professionals at this, but I like to talk about stuff that people care about. So if there's something that we're not covering, but there are some specific topics that Tony brought to the table at least, because Tony's more prepared than I am. And that is, we're going to talk about how hot Tony is. And we're gonna talk about that in a minute, and then we're gonna talk about some of Tony's hardware, because I guess Tony's gotten some new toys. And
I got some new toys. I definitely want to share. I'm excited.
Right, and then if time permits and it makes sense, I'll talk a bit about cloud network connectivity, because that's what I talk about all the time, and it's something that I can just chat about without necessarily having to prepare a ton. And I think that people are interested, or maybe they don't even know what I do. So maybe this might, peel back the curtains about what my day job's all about. The answer is scalding. I like it. How hot is Tony? The answer is scalding. So yeah, I think it's a plan, but first it's always fun to catch up. Tony, how's your week been, man?
The week's been pretty good. I think last stream I mentioned, things come in waves. It has ups and downs, and I'm on the upswing of a project. I'm getting my hands dirty. It's a lot of fun. I get to play with some cool hardware. Everything from 100 gig interfaces down to 1 gig interfaces and everything in between. So having a lot of fun.
100 gig and fancy. Yeah. I mean, there are actually a couple of servers, but there's a couple of switches that we use have a few 100 gig uplinks that we use for direct connects. I think it's becoming more common.
And what else? I'm just feeling good. It's a good week. We're coming up on a holiday weekend. I've been a boat owner for about a year and a half. About kind of when the pandemic started, my wife and her brother decided that they grew up, their dad had a boat. So you know what? They want a boat in their life. So by marriage, I became a boat owner as well. So they went and bought a used boat. And last summer, we could barely take it out. It needed repair after repair after repair, as these things typically do.
Yep.
This season, throughout the winter, we took it to the mechanic and said, hey, look, let's just take a look at everything. We want to put some money into it, but we want to get it ready for the whole season, so we want to get all the mandatory stuff out of the way. And
sure.
I think we're getting it not in the water, but getting it out of the marina and taking it to where we're going to spend 4th of July, maybe tomorrow or something. So this has been like a year waiting for this moment. And I'm getting pretty excited for that.
So is the saying true about boats that, the best day is that when you buy a boat, the second best day is when you sell it?
Probably.
Yeah, is that true? Is that accurate?
Yeah. I mean, it's just a money suck, and but you know what? It's not like a shock to me or anything. I knew that going into it. We knew that we were going to have to spend a few grand above what we paid for it just to get some repairs done and get it checked out and all this other stuff. But I guess there should be like a rule of thumb, like whatever you think you're going to spend, there has to be like a multiplier.
Yep.
Yeah, like double or triple.
Yep.
And so we're at that mark where we're like, look, if we don't take the boat out this season, it has been a terrible waste. So we're all as a family looking forward to like taking the boat out and we're going to go do 4th of July on the water. which is typical to my region. You know, if you have a boat and you live close enough to the water, you go do 4th of July on the water.
That's cool. That sounds like fun. Yeah, what's the boat's name? John just asked that. What's the boat's name?
You know,
you don't want to share it.
The boat came with a name.
Okay.
And so it has been a year in the making for us to name it. And I'm not sure what we settled on, but we have all thrown around a couple of names and have circled them around. And we did like a voting system, and it just became a very low priority to actually pick a name for this. I believe we're naming it Dolores. If my wife is on, honey, send me a text. She's probably not watching the stream. She's normally in bed. I think we're calling it Dolores, but I will tell you the name that's on the back of it right now.
What is it?
Trojan Man.
Oh, fun. So in other words, the naming is something that has to be done.
Yeah,
it has to be done.
But you know what? Naming the boat and getting the stencil printed and put on and everything, another $1,000. I mean, and that's the thing is, we're like, when you own a boat, like the things you need to do to the boat, they don't cost in like 3-figure purchases. They cost in 4-figure purchases. Everything is a 4-figure purchase. Everything.
Laz says, well, that was a name I didn't think I'd hear tonight.
So it's a funny name, and that's why we really want to get it renamed. But more than that, we just want to get it on the water and enjoy it. I don't care what the name of it is, but it's called Trojan Man because it is an F-32 Trojan. That is the name of the boat. That is I think the name of the manufacturer. And it's an F-32.
I don't think most people thought that though when they just heard the name.
So like the icon is like a Trojan helmet. You know, that's the icon of, I guess, the boat manufacturer.
Oh, okay. So, I mean, I know I don't have a vote in your naming of your whatever, but, you know, I would vote for renaming it as well. I think you need to come up, you know, Dolores.
Okay.
As much as that's really, you know, like whatever as a name is much better than what it is right now.
So we're going to call it Dolores from that Seinfeld episode.
So
where
I'm probably going to offend
remember.
people. Like, I'm not a huge Seinfeld. I've watched some Seinfeld. I think it's funny, but I wasn't like a solid follower. So Dolores, what's the Dolores reference in Seinfeld? I know. So disappointing.
Jerry gets a girlfriend or finds a girl that he likes. He goes out on a date with her or something, or he's asking her out, whatever it is. There's always a love interest in every episode. And he can't remember her name. He had only met her like once, and he can't remember her name. And he's like, they're like kissing or making out, and she's like, "Oh, Jerry," and he's like, "Oh, baby," and it becomes a part of the episode. And she goes, "You don't know my name, do you?" And he's like, "Oh, of course I do. I know your name." And she's like, "Well, what is it?" And he's like, "You know." And whatever. She gives him a clue and says it rhymes with a female body part.
Oh.
And so the entire episode is him calling her names that rhyme with female body parts and not getting the correct one until the final exit scene when she's leaving his apartment. She's storming out of there. They're breaking up, and he yells down from the balcony, "Dolores!"
Okay.
So, yeah.
That makes sense.
We are big Seinfeld fans over here.
Well, it's good. I have nothing against the show. I'm not a huge TV person. And so I'm kind of in between, like I've got a few shows that I've watched, but I just, it's been a long time since I've spent time, like really spent any time watching TV. And there are some things that I'll watch show wise, but typically they're on the streaming channels at this point. So I'll watch Netflix or I'll watch, Amazon Prime or whatever. And Seinfeld has just never been one that I've gone back around to. It seems like that would be one that would be more fun to track in real time, but I don't know, maybe not. Like I said, I've seen many Seinfeld episodes randomly, but it just never followed it. Right. And, but no, I spent a lot of time watching TV, couple weeks ago when I had nothing else going on. I was bored out of my skull during recovery. That was, I watched more TV than I probably watched in the past 5 years over the course of 2 weeks, because there's really not much else to do. But still no Seinfeld. Maybe I should. I don't know.
Yeah, I highly recommend it. I know it would make our friendship more meaningful.
Wow. Okay. So I just, essentially what I heard is I just went down a couple notches. Yeah, that boat. Yeah, the acronym, or the initialism. Although I guess this would be an acronym because you say it like a word. So the acronym.
Break out another 1,000. You got that right, Preston.
Yeah, that's that's true. So that sounds like fun. So you'll be out on the water for 4th of July. That's cool.
Yeah. Well, we hope to. It may rain in this area. Either way, we'll get out there and make the best of it. But just getting the boat out on the water and having a good time is what we're hoping to do between now and Sunday.
Nice. Yeah, we had a similar experience getting the RV outfitted, right? Like you go buy the RV and then there's a million other things you have to buy to make it, what you need it to be. And so for a while there, it was really funny. So I was taking my daughter out to see some of her friends this afternoon. I was taking her over to her friend's house, and our neighbor had like 6 packages on their front porch from Amazon. And she goes, wow, they got a lot of packages. And then the next thing she says, well, at least it's not us this time. Because when we got the RV, like every day there was like 5 or 6 packages coming in for like probably a month or a month and a half straight, as we were ordering all the stuff that we needed to make it work. And like Josiah, my son, eventually got to the point where he's just like, can we stop getting stuff? Like, when are we going to stop getting stuff? And I'm like, Josiah, it's all stuff for the RV. He's like, I know, but like, there's like 3 deliveries a day every day. I'm like, yeah, it's getting kind of absurd. So now it's not us. So my daughter recognized that. Hey, it's not us this time. Like, thanks. Make me feel great. So yeah. Let's see. What else do we have going on?
I want to talk about your background.
Yeah.
Your background is killer. If you guys don't know, Jordan, when we started this live stream, actually Jordan just had kind of a generic background up, and he showed off, he was just getting some new astrophotography gear, and he was showing off one of his pictures. And I said, hey, why don't you make that your background? Every time you get a new picture, you throw it in. And I was not expecting this one to show up. This one is super cool. So I'm loving it.
Let me see if I can't bring up a larger version of it just so people can see. That's not going to work. Let's do this. We're going to merge these two. Look at this. Okay, so yeah, so this is the picture. So this is easily the best picture that's come out of my telescope since I started. This is the Eastern Vale Nebula. It's a really, really cool target. It was really not the best night for the picture. Kind of just lucked out that I got really, really good data from it. And I've been working on processing things in a new software suite that's meant specifically for astrophotography. I kind of held off because you want to talk about expensive hobbies like boats. We could start talking about astrophotography and how expensive of a hobby that is, but we won't. I held off because I had spent enough between that and the RV, and then finally was like, you know what? Like, I'm kind of fighting ridiculous things. Like, Photoshop is not made for this. And so I went out and bought an application suite called PixInsight, which is a few $100. And so I was kind of holding off on picking it up, and I picked it up, and it's like night and day from a processing perspective. It's really nice. But this is only the second image I've put through that suite, and it's like one of those those custom made but really non-intuitive applications. Also one of the reasons why I held off, because I downloaded, like, if it made it easy, like click, 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 and it was edited and out you went. Because editing an astrophoto, like, I know it looks really dramatic and really nice now, but the actual picture you typically get out of the camera, like, there is like a little smudge that might represent something that might be there. Right. Like, and you've got to really pull that out. You got to extract it from the data that's in the picture. And that's a really delicate process to do that and not like completely distort everything. And so this is only the second one that I've used completely with that new software, and both of them have come out really nice. So I think that there's something to this, right? Like the software is helping me do it, but it's been a super steep curve. But what was interesting about this, now I'm not I'm not. I obviously use social media, but I don't use it as.
Wait a second. Let me. I just wanted to jump in. So you said that this is not the image that comes out of the camera.
Yeah.
This is what you extract from the data, right? Like captured in the image. So what does the actual image look like? I mean, this is not my world, so I don't know the difference. I assume that this is, a few pictures, you mash them together, and that's what you got. So what does an actual image captured from the camera look like compared to this very dramatic picture that you've been able to extract out of the data?
Yeah, let me we'll keep talking for a minute, and I've got some actually on the computer that's doing the streaming. Like I have them shared in Dropbox, so I'll see if I can get them pulled in as resources to kind of show you like before and after. Right? So let's oh, there's nothing in there. That's good. So anyway, I don't want to spend too much time on this, but so what comes out of it is kind of faint, and then you got to extract it all and pull that data out and kind of make it vivid so that you can see what's going on, because all of these things are super far away. They're super dim. You're collecting, light over a long period of time. And then you're taking lots of exposures and stacking them on top of each other. And so that's kind of the trick with astrophotography, is a lot of data. So this picture represents over 3.5 hours with my telescope pointed at this object, collecting 5-minute exposures. So each picture is a 5-minute exposure, right? And so those 5-minute exposures, if you do the math, that's 44 of them, right? So there's 44 exposures, and I stack them all together, and that at the end, that stacked picture pretty much just looks black. When it comes out of the stacking, there's really nothing that you can see. And then what you start doing is you start using levels and curves and different techniques to bring contrast out so you can see what's there. And then you get something like the image that's behind me. So it's really funny. You would think astrophotography is a lot of time at the telescope, and that's not really true. It's about 80% behind a computer screen, massaging the images, right? And 20% actually running the scope. Now, obviously, there's a steep learning curve to making the scope do what you want it to do. I just mentioned 5-minute exposures. Those 5-minute exposures are tracking a moving object in the sky. The object isn't moving. We are. And really the object is moving, but not at any scale that would affect your picture, right? And you have to do it to pixel perfect accuracy, because if over the course of that 5 minutes, if the Earth's rotation shifts your camera, you get star trails. I mean, you've seen the star trail pictures. They're very cool. Mm-hmm. You leave a camera long exposure up, you point it up at the sky, and you'll see the motion of the stars, because, the Earth is moving, the stars are moving in reference to where you're taking a picture. And so that's where all of the equipment comes in, right? Is countering that rotation and keeping it super, super accurate. It's a really interesting hobby. And infuriating when you don't get it right. Because you just invest all of this time into going after something, and then it's kind of okay, well, that's completely thrown away. Of all of the things that I've taken pictures of, maybe a third of them see the light of day as a final image, because there's always something about it that didn't quite come out the way you'd expect it. Where are these pictures? They're just not. Oh, I know why they're not showing up. They're not in a format. They come out as a format called FITS. Let me do this.
Either. There's a lot going on here that I have no idea what it is.
I don't want to go too deep, because most people probably just straight up don't care, which is completely okay.
I see Tom in chat said he said, I was fighting with a bit of multi-instance, multi-region, multi-spanning tree deploy this week. Pros and cons of multi-spanning tree versus MLAG architectures and or other options.
Oh, we can chat about that. I don't know that I have a great answer, but
was all that was on his mind through the week. So that's what he was doing this week.
Oh, okay. So anyway, I had a really weird experience with this picture this week. So I don't know about you, but when you do something that's something that's creative or whatever, I think we're more critical of our work than other people are. And I think this is probably true in networking as well. we talked, I think last week a bit about like designs that we kind of are. I don't think we actually talked on the show about it. I think we wanted to talk about.
We didn't talk about that. It was a private topic. Conversation. Yeah. It wasn't intended to be private. There's no secrets there, but it just wasn't something that was broadcasted. Yeah.
Right. And talking about kind of like, as we mature as engineers, looking back at some of our designs and kind of being like, I might have done that differently. Right.
Right.
So I find this with the photography as well. Like, you take a picture and you notice everything about it that's not just right. And this was the first one that came out of the camera that was like, you know what, like it could be better. It definitely could have been better. But there's nothing I could point to that said, you know what, like that. I really wish I'd done that, or I really wish that I hadn't messed that up. Like everything kind of was in place. So I knew I had a decent image out of this one. So like when I have a decent image, I like to share it. Like that's kind of the whole fun. You take this picture, you get to share it with your friends and do whatever. I posted this thing on Reddit. So there's an amateur astrophotographer subreddit because there's a subreddit for everything,
of course
right?
There is.
Yeah,
right?
Of course there is. And I posted this thing on Reddit and it just blew up. So I know it's not big for Reddit's terms, but I think it's currently at like 2,700 upvotes. It's got all kinds of comments, people asking me about stuff like I'm an expert or something in how to make this happen, which I'm not, right? Like I'm completely I'm not even a full year into it. I'm just kind of figuring stuff out. And it was kind of surprising. It was one of those things. It's like, oh, I won Reddit for the day. What do I do with imaginary internet points? Like, I'm not quite sure what I'm supposed to do with this, right? It's kind of the first time I posted anything that's kind of caught on and latched on like that. So that was my experience. That was yesterday. It was like, wow, will my phone stop blowing up now? Because like, hey, you got your first upvote. Hey, you've got 5 upvotes. Look at that. You're 100 upvotes. Oh, you hit 1,000 upvotes. Like there's notifications coming every few minutes.
Look, there it is. Did you find it? Yeah, I just went on Reddit, astrophotography.
Yep.
Which is the amateur astrophotography, and it is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. It's about the 11th or 12th post. There you go.
Right.
2.7 thousand. I mean, 2,700.
Yep.
Upvotes. How about that?
Yeah. So that
and then a bunch of Reddit swag or whatever you call these little icons.
The little awards. Yeah. First one I've ever got an award on Reddit. I'm not sure what to do with all of that. There's zero actual value, but I do appreciate the fact that people liked it, right? So at the end of the day, that's what I got out of it is like, it was cool to create something that ended up being really, really nice. So that was my experience with my astrophoto. As we're talking, if I get a second when you're kind of doing things, I'll see if we might circle back around, see if I can't get some examples of what a non-edited single capture looks like versus the final product, and it's pretty dramatic.
Yeah. So actually, there was 2 little bits of news that I wanted to bring up.
Yeah, let's chat about news.
And maybe there's some folks in the chat that might be able to lend an opinion on it. This one came out, I think, yesterday. No, not quite yesterday. Looks like Sunday is when I'm reading this article on the Hacker News. This is the Cisco Asa Flaw that was under attack after the proof of concept was posted. So this was exploiting an older CVE from 2020, and the proof of concept was recently posted, and then after that, obviously, a ton of scanning was going on and noticed out there. So this is just sort of a public service. If you got a Cisco ASA out there, make sure it's updated, please. I don't know why there's always like this. Updating equipment is so scary. You know what? It's not scary if all you've ever done is update things and it always works. It's very scary if you've experienced all I did was apply this patch. That's all I did. And then something went down in the network. So I guess whatever change management you have, whatever change windows you have, make sure you at least take a look at that and see if you're vulnerable or not. So that was a really popular one. I know Cisco ASAs are still very popular out there, FTD devices as well. The second one is, and you know what, I'll go ahead and drop a link in the chat for this first news article. That's just news article, and I think you might be able to link to the CVE is in there as well, and the proof of concept is there as well. You can get that. Here's the second one I want to talk about. This one is a Google Cloud platform, DHCP Takeover code execution. This is pretty cool. This one came out, gosh, I saw it, I don't know, the other day. Was it yesterday? Looks like this code is 5 days old in this repo. This is a proof of concept tool. So you definitely want to take a look at this if you're running some VMs in Google Cloud. The reason it kind of caught my eye, and I haven't taken a deeper look at this, is because I run EVE-NG in Google Cloud, or at least I do when I need to lab something. And we run DHCP servers in there, and I just didn't know if people running EVE-NG in Google Cloud, if this was going to affect them in any way. So we'll take a look, and if someone already has that answer, I'm all ears, and let's share the information if we know otherwise. So those were the two here. I think the GitHub link for the DHCP attack is really helpful. It has a ton of information. I think there are 2 methods in here. Looks like 3 methods to take a look at. And there's some remediation help as well. So take a look at that.
Yeah, that's cool.
Yep.
Well, I mean, not that there's vulnerabilities, but that there's stuff going on there. There's remediation available. So while you were talking, I found some. So cool. So here we go. So I'm going to merge this one on here, Tony. So this is unedited. So this is Pleiades. If you're familiar, it's called the Seven Sisters. It's just a star cluster. It's one you can see with your naked eye. Like it's something you'd be able to see.
Is that the Big Dipper?
No. I can see why you would think that. It's like I said, Pleiades. It's not a constellation. It's a star cluster. But you can see there's kind of a glow around those stars. It almost looks like a just like ambient light, right? Mm-hmm. Right. So here's the final. And so you look at that,
that's
and there's
quite a dramatic difference.
Right. There's nebulosity and whatever. So this is one of my early pictures, so it probably, I could probably do better on this now. But you can see there's detail in there and kind of like wisps of nebulosity and some of the other stuff that's out there. So yeah, there's quite a bit that goes into it. And that may not even be the best example, but like because there's actually light around it. Some of them come through and they're very, very dark and dim. Yeah. All right, so that's enough about astrophotography. Now that I've bored absolutely everybody who does not give one iota of care about the solar system or taking pictures of it.
No, but I think that's important, though, the fact that, like, I would have assumed that these pictures have just been taken with a very sophisticated piece of equipment, and that it was a single snap, like it was focused on some object in the sky, and whatever device it was, whatever camera it was, whatever they were capturing the image with, that it was a single snap and that image was in there. And it's through your astrophotography that I've become educated around stacking the images and enhancing them and some of the stuff that you've shown me and talked about. So I think it's pretty cool. It has definitely, shown me a different way to appreciate those kind of images, when previously I thought it was just, people got lucky taking a picture up at the sky with a cool piece of equipment.
Yeah, it's it's definitely a hobby unto itself for sure. Diving in and making it all happen. So Tony, I want to move on though, and I think it's time that we play How Hot Are You?
Okay. Thank God. I don't know if you guys can see, but like my head is glistening, and glowing, if you see me blinking a lot, it's because the sweat is dripping down my eyelids. Okay, so people who are regular watchers of the program here know that I'm in a workshop. I have a green screen pull down behind me, and Jordan throws up this cool digital background. But behind me is just a bunch of work shelves with tools and screw boxes and things like that on it. And so I'm out here in the workshop. I have electricity, but I don't have heating or cooling. So in the wintertime, I ran a little space heater, which was awesome. This is an insulated workshop. It's exterior walls, but it is insulated, so it holds the heat very well. it also gets very hot in the summertime. So we're in a bit of a heat wave here. I know the West Coast is under a massive heat wave, but a bit of a heat wave here for Mid-Atlantic. I think it was 100 degrees today or 99 degrees today in my region. And so I went to my office today to work where it was a cool 70 degrees in the AC. So when we decided to do streaming tonight, I said, sure, no problem. I'll jump down in the workshop. And very quickly, before we started stream, my computer started to overheat, which, as people who have watched the program know, this is a common problem. So I said, let's actually figure out what we're dealing with here. I got this cheapo temperature gun. And let's see, I'm just going to shoot it at the wall right now. 89.97 degrees. All right, I'm going to shine it on my desk surface. 91.0 on my desk. And just the face of my laptop, the 105.6.
A little warm.
That's I think there's a storm coming. I think I just heard like this, like it sounded like someone crashed into my house, but I guess it's just heavy thunder. But anyhow, it's 105 degrees. My computer's 105 degrees. And it's about 90 degrees in here. I'm sweating. My beer is sweating. And that's how hot. Oh, let's see how hot I am. 94.8.
Wow.
I would say, there's it's not the most accurate machine.
94 is a little low, isn't it? It'd be a little concerning if that was your actual temperature. Yeah.
It is. But if that's low, then that means my computer is actually like 110.
Yeah. Nice. So fan is necessary. And thankfully we have, VST plugins that have noise suppression, because otherwise we'd be hearing the buzz of the fan constantly with Tony. So I think it's all right.
Yeah,
but if you do hear the fan come through, my apologies.
A little tower fan that I have right behind my computer, just circulating air behind it. Now, it's circulating hot air, right? It's 90 degrees in here, but it's something.
So I'm interested in talking about what Thomas brought up. Multi-instance, multi-region MSTP deployment. What are the pros and cons of MSTP versus MLAG architectures or any other options? Was all that was on his mind throughout the week. And so I've had this conversation a lot, right? Like, so first off, MSTP is probably one of the better options. If you're going to run Spanning Tree, I think most engineers who've been bitten by Spanning Tree would say it'd be better if you weren't running Spanning Tree, or if you didn't have to. That is not a recommendation to turn off Spanning Tree in networks where it's actually required, because I've seen that before, because people just don't want to deal with it. And I'm like, no, you're inviting bigger problems. MSTP has some interesting components to it though, right? Because MSTP, at least on Cisco gear, I don't know if this is universal, as you make changes, there's actually slight drops in traffic as it reconverges in the network, because MSTP is coordinated. And so like to go in and add VLANs to an MSTP group can actually cause brief, not huge, but brief outages. And so I had to navigate this with one of my customers one time, because they had MSTP and MSTP was a good choice. But as they added and removed VLANs as they were created, like they had to do, like you couldn't just create a VLAN in the middle of the day or something. Like they had to time it, because they knew that they were going to drop traffic, and they were a healthcare facility and they couldn't do that. It just wasn't acceptable to drop traffic like middle of the day like that. But I don't think MLAG is the be all and end all answer either, because MLAG comes with its own complexity, right? So MLAG, we're essentially creating we're making two switches look like a single switch. And by being a single switch, we don't have to worry about the upstream or creating a loop by connecting both ports to the same one, because we can make it a port channel then. But, it depends on the implementation of MLAG that you're working in, right? Because there's multiple, and just in Cisco world, we've seen stacking. We've seen VSS, we've seen with Nexus VPC, and then we've also seen what do they call it? Virtual Stack that came out in the most recent Catalyst, which is really just seems like VSS with some slight improvements using front of switch port. So I mean, like there's some iterations, right? VPC was and is a very complicated MLAG setup. Like there's a lot of nuance to what you can and can't do, especially around routing protocols and other things like that, right? So I don't know that there's a one size fits all answer, which is probably, you know, Thomas, I know you're a smart guy, so I'm sure that that's kind of what you're facing right now is the fact that there's not a one size fits all approach to doing it. They both have drawbacks. I personally, in access networks actually lean back towards spanning tree as much as people don't like it, as much as possible because of the fact that it's a proven technology that once it's set up correctly does not really need to be managed. The challenge around spanning tree is setting it up correctly and putting the protections in place to make sure you don't have an accidental new root show up, that you know you have your root guard and BPDU guard and some of those other components for spanning tree in place. And so I think that, you know, if designed correctly, spanning tree is not as scary as a lot of people make it out to be. I think people have dealt with misconfigurations or lack of thought around spanning tree. And so I think that that's really the big deal. So I'm not necessarily anti-spanning tree, but I'd much rather deal with a fabric because that's kind of where I've been living recently and dealing with these overlay fabrics where like spanning tree just straight up isn't a thing. But access networks aren't that, right? Like it's just not, as much as we'd like to talk about it, the access network is still the access network. Like you're not really typically running unless you're gone all in on like software defined access or some other, you know, campus fabric style, you know, design, which has its own concerns around complexity. I still would lean towards spanning tree. I don't know if you have thoughts, Tony, but
no, actually I haven't done a lot in very heavily switched environments. I'm not a Nexus guy. I've done plenty of switch stacking, and different models and different vendors have their own limitations with that. But I'm inside the data center dealing with like big core switches, doing VPC or VSS. I think VSS is what I remember on the 6509s.
Yep. Early Catalyst. Yep.
I would come into networks that had that already. The 6509s are a fun animal, but no, my focus was always in supporting those kind of environments. My focus was always on the routed edge.
Right.
Switching was pretty basic. There wasn't much to be concerned of.
Yeah. So I think VSS, if I had to pick an MLAG technology, that's the one that's kind of been the most stable. It's not perfect. And there's some inefficiency with it because there's just a single control plane for multiple switches or for two switches, right? So when you talk about VSS, the differences between VSS and VPC, VSS is, you know, we take multiple ports, connect the two switches up, but only one control plane is active. And essentially the second switch becomes a dummy switch. Now it can switch over and start running the control plane if the first one goes offline, which is part of that, you know, redundancy. But by making it that way, it's a lot simpler from a coordination perspective, but it's not as efficient because anything that needs to be routed, anything that needs to be switched outside of the ASIC, anything that has to like jump to another line card or do something else, typically has to go and hit, you know, wherever the control plane is living, meaning that if the packet comes in on the slave switch and that VSS setup, then, you know, like it's got to go across the link and then possibly back out some other way. And so determining traffic patterns and some other things are a consideration. Stacks are the same way, right? You can have a stack of, you know, up to 8 or 9 switches depending on the line of switch, and don't do that, but you can, right? And with that, only one of them is actively running the control plane. All the rest of them are just essentially extensions of ports. It's almost like having a line card, right? Yep. And so with that, anything that has to traverse has to go around that loop that's plugged in on the back, right? And so like there's, typically for access, this isn't a big deal. You've got, several hundred 1 gig ports, but most people are connected, and actually sending a whole lot less data than that. And then your backplane is like 40 or 80 gigabits per second. And most people do not overrun the backplane capability of their switch. But if you try to do some advanced features, you could run into some fun things. So let's try doing policy-based routing or something like that on stack switches, and all of a sudden you get into some real fun things when it has to punt to the CPU. So like it gets very interesting. So like stacking and VSS are there, but the VPC is a beast in itself. In fact, Laz said VPC is scary, yo. Every time you muck with it, you take your uptime into your hands, and it's true, because with VPC, those are some really weird smiley faces that come through on the banner. They look scary. It's like vampires or something. When you talk about VPC as a MLAG solution, the whole point is not to have that single control plane. Both switches run their own control plane, but they coordinate. And the idea is that it should be very, very rare that you have to send traffic from one switch to the other. The idea is they both share things like MAC tables and adjacencies, and they understand what's going on the other switch, so they know how to treat a port channel. But as packets come in, I'm watching you. That gets even more creepy with those things on the screen. I'm taking them off. Right. But the idea behind VPC and the whole thought behind it is like, let's make this thing as efficient as possible. Meaning that we don't send packets to another switch unnecessarily. We process them on the switch that they come in and send them out. But it creates all kinds of fun requirements, like if you don't have everything dual homed, it becomes a problem. So the assumption here is that everything that's connected to a data center switch is dual homed, which in a perfect world, that's exactly what happens. If you're designing a data center from the ground up and it's greenfield, 100% connect everything to both switches. Like that's the way you do it. You go into environments that have been around for a decade or more and you're putting in Nexus and replacing Catalyst, I guarantee you about 3/4 of the stuff's not dual homed. And so you end up like with these scenarios of which you're trying to mitigate things like orphaned ports and things like if one of the control planes goes down, it will shut down all of the SVIs. Right. And there are ways to mitigate it, but it's kind of working against the protection mechanisms. And so like I think that MLAG comes with a lot of complexity. It's not awful, right? It's definitely not awful. And in access networks, it's super common. But I would much rather, and this is just now the engineer in me who says it should really be this way. Back when they were designing networking, like switching wasn't a thing. Like so everything was routed. And when you talk about the way they designed some of the protocols early on, everything was planned to be routed. The host was going to have an address. It was going to route with its upstream switch or router, right? And everything was a routed environment. And when you think about like dual homed routed links, it's not common because we typically don't have routing protocols on servers, right? But if you had dual homed routed links, it just becomes another node with redundant connectivity that just has to make a decision about what the best path is. Or if they're equal, we can spread traffic across both of them doing equal cost load balancing. So I think that the routed solution makes so much more sense to me, but like, what desktop PC are you going to connect in a dual homed routed connectivity? Or if you have that edge switch, like I would much rather design that as routed, like each closet, maybe the closet has a stack, but then it's routed to distribution and then routed to core. But most networks just straight aren't built that way, even though that was Cisco's design forever, the 3-tier. Here's your access network. People say, I need this VLAN everywhere. And the next thing you know, all the VLANs live on the core switch. They're spread out with spanning tree and they go absolutely everywhere in the environment. Then when you do have a bridging loop, spanning tree has failed you, everything goes down. The whole thing just comes falling down. So I don't know that there's a right answer. Laz asked about VXLAN, EVPN, and a vanilla enterprise. Worth it or not? What are we implementing on?
Yeah. What's this? What? Well, I was going to say, what's the problem that you're trying to solve?
Well, by creating a VXLAN or EVPN overlay, using VXLAN as kind of the segmentation protocol using EVPN for connectivity, it becomes routed. Right, so your individual switch, like if you need a VLAN, you can deliver a VLAN to any switch, but the interaction between switches is a routed interaction, so you don't have the same failure domain that you would by a spread out L2 environment.
Right.
And
so the underlay there is a routed environment, but the overlay is a layer 2 environment.
Or layer 3. It could go either way. But yes, you can essentially extend L2 over L3. And so I think that...
It's starting to sound like Kevin Myers.
Well, I mean, but this is the panacea, right? The idea, and he being working in service provider, right, extends L2 everywhere. We have this fun little back and forth conversation all the time. Me working in the corporate and enterprise world, big global companies, whatever, they're not typically deploying service provider style networks. And in that case, when you have to deal with the applications, extending L2 becomes a big, big nightmare if you extend it over lots of area or lots of distance, because your blast radius just becomes so huge and significant. In the service provider world, they stretch L2 all the time, but they're stretching other people's L2, right? So they have L2 riding over the top of L3. You don't see any of them that are necessarily building an L2 underlay. Because if you talk to service provider people, like they're super interested in making sure that everything is routed. They'll stretch L2 to get adjacency for things, but they're not necessarily dealing with the same type of enterprise applications that those of us who work in that space are. And so there is valid reasons to do it. I'm not a fan of like stretching L2 to connect data centers though. Like there's a lot of reasons not to do that. If you're calling that your disaster recovery, you don't have disaster recovery. You have 2 data centers. That's cool and that's good. But disaster recovery means we've removed shared fate. If one goes down, the other one doesn't go down. If you stretched L2, that's straight up not the case, right? Like you've now shared fate between the two. And so VXLAN and EVPN, back to the question. So I will say implementing this on Cisco equipment is incredibly difficult. Like if you can do it with automation. I saw a tweet this week about it, actually. Somebody from another vendor, so I won't actually say who it was. And if you saw the tweet, you'll know exactly what I'm talking about. If Cisco equipment can do it, but EVPN, like the config, like it is rather involved on each of the switches to get VXLAN and EVPN up and configured and working. Cisco's answer to this, by the way, in the campus network is software-defined access, which has its own complexities and costs that come away with, DNA center and some of those other things. Yes, thank you, Next Top Self. Absolutely. Stretch L2 between DCs, you have one DC. Yes, that's true. You might have 2 physical locations, but not two unique and disparate DCs. So I mean, like, it's an excellent question and something to consider, right? Like, what is the right way to go about it? But fabrics make a lot of sense, but I think fabrics have been adopted in the data center a lot more, because there's a lot more control. I think when you get to the campus or access network, it's more of a question mark about whether or not that makes sense. I mean, there's products out there that will do it, that will create these fabrics for you, or you can do it yourself. But I'm not seeing a lot of people do it, right, in the access networks. They're not seeing a lot of value. We do have customers who are running software-defined access, though. So, I mean, but they tend to be shops that are all Cisco, and they're just doing the next thing that Cisco does, and there's value out of it. It's just an involved and sometimes expensive proposition. What else have we got in here? Thomas was going on like crazy about stuff here. Let's see. Designing heavily redundant. Oh, what's up?
I was going to say, I was just having a little fun in the chat with Zero Tier with Laz, and it was this week? This week, Zero Tier saved my butt. So I want to give a short Zero Tier story.
Go for it.
Actually, I think it was last Friday, as a matter of fact. It was going into the weekend. I got called in after a cloud environment was built and after an on-prem environment was built. They just needed these 2 environments to talk to each other, and they didn't bother involving anybody on how to do that. Both are behind NAT. One of them's behind a double NAT, and they're trying to use IPsec to build a tunnel to the both of them without port forwarding capabilities on any of the NAT boundaries. So after hours of them failing and trying to troubleshoot and everything that I could possibly help them with IPsec, I said, you know what, let's just jump on Zero Tier and just see if this thing works. Installed a zero-tier agent on the client, took all of 1 minute. Installed a zero-tier agent on one of the test servers, took all of 30 seconds. I authorized both of them in the console, and then they could reach each other. The whole operation took about 2 minutes. We spent hours troubleshooting IPsec.
Nice.
You know what I mean? And this was just for like a proof of concept for a demo, not involving zero-tier. And I'll say this, I say it every time, Jordan. The beauty about zero-tier is not the product itself. It's about how it enables you to do other things.
Right.
Right? So we weren't demoing zero-tier as some like VPN solution we're bringing to the table. It was like, no, I just need this thing to talk to this thing. Well, how am I going to stitch it together? Boom. In as least amount of time with as fewest commands as possible. It's the simplest solution. And saved our butts.
There you go.
Yeah, so another plug for zero-tier. I'm a fan, and I don't have any reason not to be at this point. Let the hymn begin.
Yes. There is an unhealthy obsession with zero-tier in the Network Collective Slack. I don't know where that came from. I mean, don't get me wrong. I see the value. And we're using it here. Tony can kick off stuff on my machine through zero-tier.
Yeah, that soundboard, the soundboard that I'm using is on Jordan's PC.
And we're a couple hundred miles apart, and it's like we're adjacent, and it's quite effective as a tool. But yeah, it's a tool, right? Just like everything else. And so new members join the Network Collective Slack, and it's immediately, have you met my Lord and Savior? You know, like it's a little creepy cultish sometimes.
It's so true. Yes. The Kool-Aid's delicious.
The Kool-Aid is delicious. If I was just walking into a new community and that's how I was greeted, I'd be kind of, maybe I should, can I ask for my money back now? Yeah. But yeah, so it's, it is a great tool, and I'm glad to hear that it worked for you. I have some use cases for it as well in the near future that is really just connecting into environments. I'm really just kind of getting fed up with traditional VPN in a couple of ways. It just kind of gets in the way. I'm trying to demo when I need to be on VPN, but that means all of my traffic is now going back to my headquarters in St. Louis. And I'm just like, really, like, I just need access to like these two resources. Can I just make that happen? And so that's zero-tier. That's cool. I'm glad that saved you some time. We got, let's see if there's any other topics in here people want to talk about. Let's see. Yeah, so Thomas was talking about overlays as well. He says, yeah, overlays were a part of his dilemma. He says, do I want to introduce a ton of complexity for VPLS, VXLAN, et cetera? Is the complexity acceptable or even wanted? And that's really the question, right? What are you getting for the additional time or effort or, like, again, when I design networks, I mean, we were having this conversation about like how much complexity is too much, and well, maybe it's just worth kind of hashing that out. Like when I started, and Tony, I know you agree with this because of our chat. When I started, like I wanted to be working on the complex networks. So when I started, right, like they don't let you touch the big important stuff. So you're always like at the access side, or you're doing something minimal, and then you get more and more exposure. And it's always like we're aspiring to get to like that core, the thing. And really what I think is
but there's always someone who is doing that. You know, while you're at the access layer, managing switch ports or what have you, there is someone who, for lack of a better word, you're sort of putting on a pedestal. They're doing the complex stuff.
The routing,
I tell you what, they're doing the networking that you think they're doing complex stuff. Well, what they're really doing is their job.
Right. And what we talked about was that, I think, I don't know if it's everybody, I'm not going to say everybody, but I think a lot of engineers kind of have this when they start, or people who aspire to be engineers. I don't want to be just the tech who's just kind of like doing the grunt work and making it happen. I want to be part of the architecture, the design. I want to be in the nuts and bolts and making it happen. And so we study and we learn and we do all the things and we learn how to do all the really complex things. And then we get there and then we start working at it. And what I've realized is that I don't necessarily want to be working on the complex. I want to have the ability to, if and when that's required. What I really wanted, and I didn't think I could articulate before, is I wanted to work on the stuff that mattered. Right? So to me, that's the difference. Like I always used to think that was complicated. Yeah.
And just that thing, I think, is the perfect way to phrase that. And I too have felt the same thing. When I first got in, I thought that the people above me, so to speak, were doing the really complex things, and I aspired to work on their kind of projects and to do what they were doing. So I studied complex topologies and complex ways of solving problems and things like that. And this actually led us into a different discussion, you and I, that had this, but you're absolutely right. When I was starting, I wanted to do the complex. But as you mature, what you realized is you wanted to do what mattered.
Right.
And you thought that the complex mattered. And now, as a mature engineer, it's not complex versus simple, where it's one is right and one is wrong. It's whatever solution is right is right.
Right. I will always,
as long as you're working on something that matters.
Right. It's really funny because I always used to aspire to this, and this was part of our conversation as well. Oftentimes the aspiration to that means that you start implementing these things as you learn about them. This is super common for CCIEs. I can't tell you how many times I've walked in to the network of somebody who's studying for their CCIE, and it's one of the most complicated networks I've ever walked in and had to deal with. Right.
Yeah. And it's true. And it's true that when you walk in there, they tell you, oh, well, the guy who designed this, he was a CCIE. And you're like, oh, gosh. Mm-hmm. And I know that's 100% true because I went through that growing process myself.
Yep.
Okay. Not just my CCIE. When I was just learning networking, the more things that I learned, the more corner cases and the more nerd knobs I learned what their function was and how to use them, or what I thought maybe how to use them. Maybe I used them incorrectly. But anytime I saw a problem in a network or a problem that needed a solution, I would say, oh, hey, I was just studying this last night. I have a solution. We'll create these 3 VRFs and we'll stitch them. It's just like right there, it was already too complicated.
Right.
Didn't need that.
And so, Tony, I think your point is right. I don't think complexity in and of itself is something to be avoided. Sometimes complex problems require complex solutions. That's just the way things work. I think that when you think about complexity, though, I think hopefully engineers are maturing. I know that when I now look at things, it is the simplest possible solution that will solve my problem. Right. So when presented with 2 or 3 options that can solve the problem the same way, I'm going to be biased towards the simplest, where maybe early in my career, I would have been biased towards the more complex because you can do more with that. But I don't need all that other stuff. I need X, Y, and Z. And it's really funny because we see this on the way up, who would use RIP as a protocol? RIP is just no good compared to what else we have. EIGRP, OSPF, IS to IS, whatever, BGP. Where the reality is sometimes RIP is the absolute perfect protocol for what you're doing. It's not often, but it's really simple. It's not complicated at all. It can pass routes. And so long as you're not talking about huge amounts of distance and you're not talking about a huge amounts of routes with regular updates, it's a completely acceptable protocol.
And you know what else? I was just thinking, and maybe this is not a point of concern anymore, given the time and age that we're in with computing and compute resources. But I wonder, from a compute and memory resource comparison, which routing protocol is the most minimalist? Is it RIP? Is it EIGRP? Is it OSPF? I mean, if you put them all in the same topology, which is the least intensive to run? That's a Donald Sharp question.
Right. I think OSPF goes out. I think IS to IS go out. Anything with Dijkstra's algorithm, although it's only when changes happen. So I guess there's a question here is how much churn is in the network, right? RIP is a super predictable. It just re-advertises at an interval. right? So that is both inefficient and efficient, depending on how you configure it and what's there. And then EIGRP is interesting depending, again, it depends on the environment. Oh man, I'm such a consultant. It depends. Everything is, it depends. Like I could see each of them. John says statics, and he's right. Statics are the most processor effective, but we did say routing protocol. So I'm not going to include statics in a protocol. But you get the idea. I mean, it's really dependent upon the environment. So if there's not a lot of churn in the links, EIGRP is probably very efficient, right? But if you get into active situations where it's needing to query routes from neighbors, it's going to be very not efficient or very inefficient, right? Like OSPF is, the calculations that are required are pretty intense on OSPF because every device has the whole network. So on a small network, OSPF is probably not that big of a deal, but on a large network, where you're calculating the entire topology without modularization in areas and kind of reducing that churn, all of a sudden that OSPF calculation is going to be pretty intense up front, but then isn't going to necessarily need to be recalculated a lot unless there's churn, networks being added and removed. And so I don't know. I think that there's a lot. I think there's a lot to consider in that question. I don't think there's one answer. I think that's the reason why RIP is sometimes applicable as a protocol, and then other times you're using something else. And so, yeah, it'd be interesting. I don't know. I'd be curious on Donald Sharp's opinion as well, because he's actually had to deal with like the down in the memory stuff. So he probably knows more than I do. Oh, he definitely knows more than I do. Who am I kidding? So yeah, but I think that there's components to that. So that was. OSPF wishes it was ISIS, and yes, you're right. ISIS is I think a superior protocol, a superior Dijkstra protocol for sure.
Now, and I think Kevin even said on there, I know it was next top self. Sometimes host routing with RIP makes sense. Think Windows. I didn't even think Windows supported any routing protocols, but I guess it does support RIP.
Yep.
Okay. Yeah. Why? I don't know, but okay.
Because of this very reason. So again, I mean, when we did the history of networking with Radia Perlman, right? She didn't even know like really why we were developing a layer 2 mechanism or protocol to prevent loops. Like she thought it was ridiculous because we had ES to IS and IS to IS. Like we had protocols to handle this. When networking was originally created, everything was routing. So the idea of an endpoint having routing. Now the question is, when did Windows come along in the course of networking history, right? But whoever wrote that stack way back when Windows was first Windows, or whoever they stole it from, whatever, right? Wherever that networking stack came from, I guarantee you that person had experience in networking before switching was as prevalent as it is today, right? And the idea that an end host would have to route was not an uncommon thought. It seems odd now, but historically it wasn't odd. The idea that the end host routed, was kind of the way it was all designed. And then we added switching and bastardized it all. And then we got spanning tree, and now we all hate spanning tree. And we can thank L2 networks for that.
I want to talk about that episode real quick. The Radia Perlman History of Networking episode is hands down one of my absolute favorite, top 5 absolutely for sure. I still remember. Actually, I'm saying that I'm remembering it, and I'm going to try and quote it, and I'm going to get the quote wrong. So I remember at that time hearing this little tidbit and thinking to myself, like, it was at that moment, spanning tree all of a sudden made sense. Listening to her talk about it. And one of the things was that she talked about like how much memory space it needed or for some reason, and it was very, very little, like 2 bytes or 3 bytes or something. She needed like 3 bytes of memory or something for this all to work. And it was like, what do you mean 3 bytes of memory? How did you get away with that? And it was because like, each port only needed to remember the best bridge ID. So if another one came in that beat it, it threw that one out and just replaced it with that one. And so you were only ever remembering one bridge ID. That was all you needed. And I just thought that was absolutely brilliant. You know, it wasn't looking up this long database and comparing them in some algorithm or something. It was doing very simple math and just throwing the other bits away, right? And just holding one value in memory. And it was like at that moment in time when I heard that, I was like, oh, that makes perfect sense. like it couldn't be any more simpler. Like to me, that was like the realization of simplest is best.
Yeah.
Right. It wasn't holding a bunch of things in memory and building a database and all this other stuff. It was just do a comparison, throw the bad one out. That's it. That's all you needed. Perfect. Simple.
So Kevin missed our earlier conversation. He says MSTP is the most underrated protocol of the spanning trees, and I couldn't agree with that more. With the one caveat that I brought up before about updates potentially impacting traffic. Beyond that, from an efficiency standpoint, a compatibility standpoint, I mean, again, I've mentioned it a lot. I work primarily in Cisco networks, and so with Cisco, right, like they have their per VLAN, and then it gets really complicated when you start integrating with non-Cisco equipment, because when you run traditional spanning tree or rapid spanning tree, that's not per VLAN. Now all of a sudden, you know, VLAN 1 is the one that matters, and you can't just get rid of VLAN 1 because VLAN 1 is going to determine the tree, and getting in and out of you know, per VLAN into non-per VLAN, back into per VLAN, and like all of the complexity that it causes. MSTP is good across the board, right? Like MSTP is just easy to work with. So I agree with you, Kevin, completely. Windows networking was originally BSD. I think Donald might be behind. He might have paused because he's responding to our stuff, but he's responding much later than everybody else. So he did answer. He says there's no set answer. He says part of the decision for like from routing protocol will be the CPU and memory speeds as well. So for those who don't know, who might be watching or listening either in real time or later, Donald Sharp spent some time working on the code at Cisco for routing protocols, and currently now works at Cumulus NVIDIA. I guess I have to include them in there now because of the acquisition, and works as I don't know if it's lead or core developer on free range routing. So sorry if I butchered your title, Donald. You're a big deal at free range routing. So I think out of everyone, we should at least listen to what he has to say about when it comes to the efficiency of protocols in code, because he's spent quite a bit there. Right. So Laz says maybe he's behind on the video. I think so. I think he's paused it. So he's gonna respond to everything I just said like 5 minutes from now.
Do you remember when Kevin like paused our live stream one night for like 30 minutes?
Yeah, and then
he came
like
back and he was like he was chatting a whole bunch, and it was really late, and he had no idea what was going on.
Right. I do remember that. Okay. So what else we got to talk about here?
I got a couple of little pieces of hardware, and we have some cloudy stuff to talk about.
We can talk about cloudy stuff. There it was. I was behind. Yeah, it's okay, Donald. No stress.
Let me show you guys these couple of pieces of hardware. These are just some small, quick ones that, you know, we all have our hobbies. You know, Jordan's throwing down on some astrophotography gear, and I normally don't buy like computer gear or networking gear for my house. I normally repurpose old stuff. I find like an old computer, like my son's computer. I bought it from a yard sale for $100. I put an SSD in it, upgraded to Windows 10. Boom, he's got a computer. Happy to have it. So I'm that kind of guy. I like to keep things as simple as possible, but lately I'm diving in. I'm actually putting some money into this. And so I have a rule that anything in my network closet, which is actually just a closet with some wooden shelves with some gear on it, everything in there has to be silent, fanless, passive cooled, everything. And that's because it's in my basement, and I don't have like a proper theater room. I know I'm doing a lot of quotey fingers. I don't have a proper theater room, but I do have a projector and a 10-foot screen down there, and we watch movies. So I can't have like a screaming server down there, because it's not a soundproof room. It's, you know, there's not enough soundproofing to silence screaming servers. So I have a rule down there: everything has to be passively cooled and silent. So a Supermicro came out with this baby. What?
There's not enough soundproofing to silence screaming servers except for in every TV show ever created. This is a game my wife and I pointed out to my wife one time, now it's a game that she plays. And now that I bring it up, you guys are going to notice it if you haven't already. It started with 24. So in 24, the TV show 24, the server room was like right in the main office. And like, it was just behind a glass wall.
It didn't make a sound.
No, what would happen is people would duck into the server room to make calls. And I'm like, nonsense. Nope, not happening. Doesn't happen because there's like 15 racks of servers that are all supposedly just going like crazy, right? Like, and all of us have,
blinking and everything.
All of us have been in that environment. You know how loud that environment is. You leave that room to make phone calls. You don't go into that room to make phone calls. So I pointed that to my wife because my wife obviously doesn't spend time in colos and data centers like I do, and now every single time she's the one that takes exception when they show a data center, and it happens all the time. People on phones standing right behind a completely full set of racks. And it's just like, no, definitely not. So sorry to interrupt, but apparently in TV world, that is possible. So you need to figure out what they're doing because they're not just
in my basement.
They not only have the soundproofing for the room, but within the room itself, it is hundreds of running servers and completely quiet.
Yeah. So Supermicro came out with this baby. This is it looks a little weird on the green screen with the green screen background, but this is basically just a bunch of heatsink ribs. This is a Xeon D, 32 gigs of RAM, two 10 gig SFPs there, two 10 gig Ethernet, and four 1 gig Ethernet and IPMI. So you can get this a couple of different ways. And, I mean, it looks a little ridiculous. It's heavy as hell because I guess it's aluminum or steel. I think it's steel. My buddy thinks it's aluminum. I don't really care. The fact is it's silent. You power it on and it doesn't make any more noise than it's powered off. So it's absolutely very cool. And this is going to be my Vios router. So you guys know a couple of weeks ago, I posted a blog. I'm running a Vios router here at home with an integrated Suricata IPS. I have that running in a container on the same box. That box is essentially the same exact box as this one, except that one has fans in it. And so they're not screamers, but they are loud. So I'm going to replace that one, which is one of my company's boxes. Proof of concept demo kit that I was playing with, and I'm going to return that and actually put this in working order. So that's very cool. This was a big purchase, right? This is a 4-figure purchase. I normally don't make those kind of computer purchases. That's not my thing. But yeah, I spent some money on it, and I'm going to do a bunch of stuff with it. The other things are, I'll do these really quick. I also saw Dualcomm came out with a 10 gig tap. Look how small this thing is. If anyone's, you guys know I do a bunch of packet analysis and network visibility, so taps are everywhere. In the enterprise world, a big fan of Gigamon. Let me see. There you go. Rep it. Big fan of Gigamon. And but anyhow, Dualcomm has always made these like little taps, these little tiny ones for like 1 gig. This one's 10 gig. So this is SFPs on both ends. Right, so 2 network ports, and then a monitor port on each side. So this is a non-aggregating tap, right? What that means is if you're tapping 10 gigs, you're tapping 10 gigs of transmit and receive, right? So that outputs 20 gigs of data. So if you have 2 inputs, you should have 2 outputs. So this has 2 outputs. It's non-aggregating. So you would need 2 10 gig ports to listen on this. But it was pretty cheap, and I say pretty cheap for a 10 gig tap, I should say, relatively speaking. And I'm very excited to use it. So I'm just waiting for the SFPs to come in and get that running. And then, of course, I have their other cheap one. This is actually, I went on their website to buy this and saw the other one and bought both. So again, I don't normally spend money on computer gear, but I splurged a little bit because I don't spend money on it. And I was like, you know what? I'm old enough. I'm a big boy now. This one is a 1 gig tap. So look at this little box. I mean, it's about the size of a wallet. I can throw this in my backpack and I have a 1 gig tap. Now, this is an aggregating tap, right? It has 2 ports that you put in line with your device, whatever you're tapping, and then it only has 1 output. So that means you're taking in 1 gig on both sides, which aggregates to 2 gigs, but you can only output 1 gig. So that means you can't actually tap a full 1 gig fully saturated line, right? So this would be good for like a desktop PC, VoIP phones, most equipment. Most 1 gig equipment isn't piping out 1 gig full transmit and receive the whole time. So so if you do, you need to be aware of that and make sure you're using the right gear for tapping. But this one is pretty cheap. And it's even though it's a DC power input, it comes 5 volt out of USB. So no extra adapters. You know, you just plug in your USB to barrel connector. And that's it. So got these things, and I'm very excited. Capture all the things, man.
Capture all the things.
That's it.
I'm a big boy. I can do it now. That's funny.
Yeah, I you know, my wife is in charge of the finances here. You know, that's the way we run our household. And you know, if I'm going to spend a couple $100, it's not a problem. You know, but if I'm going to make a 4-figure purchase, I need to get approval. There needs to be some budgeting.
Need to put in the requisition and get sign off.
And that didn't happen this time. And I just said, you know what? I'm a big boy. I make good money. I'm buying what I want.
Does your wife know?
She knows. She's not happy about it, but she knows.
Nice.
So that's my new gear. As soon as I get some time, I'm going to get this passive guy plugged in downstairs to replace my proof of concept box on loan from my company, and continue playing around. I kind of want to see what this passive one is going to do. I'm not putting a heavy workload on it. I'm running full inline IPS and Vios router. Probably I'll throw a couple extra containers on there. I have 1 gigabit uplink to my ISP. I got 10 gigabits in the house between my switches. I'm not pushing 10 gigs of traffic, you know, so it's not really doing a heavy workload. I don't expect it to get too hot, but it's just kind of an experiment. And I wanted to see how it was going to work.
That's cool.
Yep, that's all I got.
Looks like fun. So we're going to talk about cloudy stuff, huh?
Yeah, man.
Is that next? All right. So
I would love to.
Yeah. So I don't know how many people know what I do, right? Like, obviously they know what I do here. They know I'm a network engineer. And I think most people know that I work for Worldwide Technology, right? So like, I think that that's a pretty good baseline. Now, when I started there, I was doing a lot with SD-WAN. I think people knew that when I went there because I was pretty deep into SD-WAN. I was also deep into Nexus and a bunch of other things that have since started to fade away because I'm just not touching them nearly as much. But somewhere along the path there at WWT, I got introduced to some new technology around cloud connectivity, and cloud networking was really something that was on my horizon that I wanted to get involved in and start really learning, because obviously it's affecting, I think, most of us who work in the enterprise space, enterprise, corporate, even down to small, medium office, right? Like it's the cloud is just starting to become a consuming factor when it comes to networking. And what I find is interesting, right, is that cloud very early, and even now, well, maybe not as much now, but we're starting to realize a change in this, was very much positioned as a way to kind of get around those slow networking people. You can go and you can deploy it. The networking is simple. You don't need, some fancy network engineer to come in and tell you why your idea is stupid and why you shouldn't do it that way, and how you should put all of these layers of complexity and security and all these things around your connectivity. Forget all about that. Just come in, deploy your server. It's got connectivity to the world, and you're golden. You've got a service that is you've got a service that is running and available, whether you're talking about development or you're talking about something in production. It's kind of the way we went. And since then it's matured a bit, right? And that narrative has changed just a little bit, in so much as that it's like, okay, well, we need to put some constraints around connecting, but we just really need to connect to the cloud, to our on-premises stuff, like get it back to our data center so that the two can talk. And that's where we see a lot of the things that have come out, and are used heavily in the past few years, either IPsec VPNs, private connectivity, or like direct connect, express route, those types of technologies to get to the cloud. And that makes a lot of sense, if you've got a single cloud environment. But kind of the big and predominant trend that's been going on is multi-cloud. And it's I think there's a lot of pushback. I was one of the first ones who was like, multi-cloud, really? Like, when cloud gets propositioned, especially when you talk about hybrid cloud, everyone talks about, I'm going to move workloads from one to the other, kind of like on the fly, and I can move from here to there. Maybe that exists, but I don't see that, right? Like I'm not seeing that. That's not really a primary driver for multi-cloud. But honestly, there's a lot of reasons why multi-cloud might be a reality for a lot of companies. And multi-cloud, I forget who told me this. I really wish I do remember so I could attribute it correctly. But basically, like every organization's one merger or acquisition away from being a multi-cloud company. If you've settled on AWS and the company you're merging or acquiring, or they're acquiring you or whatever, is an Azure company, guess what? Tomorrow you're a multi-cloud company. Like that's just the way that it works. And there's a lot of other things that are happening. People are finding that the different clouds are kind of performing it different ways and do different things better. So sometimes it's better if you're talking about, big data applications, like Google Cloud is kind of known for that. The performance around those deep like data lakes and things like that is Google Cloud's like sweet spot. AWS has all kinds of like platform as a service and components that they do. Azure obviously tied deeply into Office 365 and the Windows stack. Not just that, there's other cloud components as well, but they all have their strengths. And so I think that it's not going to be, science fiction to see companies placing workloads in specific clouds for the value that cloud provides. And so one of the other narratives around multi-cloud is this idea of independence. Like I could pull a workload if anything gets, if all of a sudden AWS decides that they would just want to screw over all their customers and raise pricing by 50%, I'm not stuck there, right? Because all of the clouds, and of course it's not really a realistic expectation, but the idea that the clouds do try to lock you in. There's no doubt about it. When you use the native constructs, they are different from every other cloud. There's no standards between them. And so what I think people are finding and discovering is that those methods of connecting just aren't kind of hashing it anymore. It's just not meeting the needs. And so there are some really interesting technologies that are out there around a multi-cloud connectivity, because when you start talking about like, okay, now I've got to build connections into each of these clouds. I've got to understand the native constructs of each, which are wildly different depending which cloud environment you're in. AWS has things like Transit Gateway. The same way you do that in Azure, well, there's not an immediate and exact way that you do that in Azure. They've kind of got something that's similar, but it behaves completely differently. And forget about in Google. Google is different than everybody, right? So like you've got to go and now become experts in 3 different networking environments on top of being your on-premises network engineer. That's really, really challenging. And so like this is what I early on in SD-WAN, not to pat myself on the back, but I could see early on that SD-WAN was going to hit, not because SD-WAN did anything that was like magical or special, but because it met needs of organizations where they sat today. It allowed them to use complex technologies without having to invest so much into those, into learning how to manage those individually and then make them work together. You didn't need the brilliant network engineer to stitch together, BFD, complete overlay network, application-based routing. You didn't need someone to stitch all that together because that's what the controller did for you, and you kind of built a fabric, and it was built on all this stuff. And so that made a lot of sense to me. And again, not that we couldn't do it before, but because of the fact when you put it in this package and made it accessible, someone could write a check rather than investing, right, wrong, or indifferent, into engineering capabilities. Companies will choose that, 11 times out of every 10 options they have. They'd rather buy the thing that makes it go than whatever. So working in that space, I'm seeing the same problem set and almost a very similar solution set come out around meeting cloud connectivity needs. And I guarantee you every person I work with who works at one of these companies that I'm going to bring up would like punch me in the face for me to say this, but I say it all the time and they're going to have to deal with it. It's SD-WAN for cloud connectivity. It's software defined networking, right? So all of the same constructs are there. And before I go any further, I want to bring up, like, tonight, I want to talk a bit about Aviatrix, only because it's probably the one that I've worked the most in, not because it's the only solution on the market. There's another solution called Alkira, which is really good as well. F5 has a solution called Volterra. There's a bunch out there that are kind of meeting this particular need, but it's overlay networking for cloud connectivity. And at the heart of it, really what it's doing is it's abstracting away a lot of that cloud networking stuff, right? So as an endpoint engineer, but it's also giving you some tools and some additional things that you don't get in the cloud that I think traditional network engineers would appreciate. Even if you're not multi-cloud, there's like a use case for using this stuff because of the fact of what it gives you. And it's really, really simple stuff. So simple things like ping and trace route from multiple places within the cloud. So let me ask you a question, right? Like if you were, Tony, how much cloud networking do you do? How often are you in?
Very, very little, very little. I told you just on Friday I had to help failing to stand up an IPsec tunnel between AWS and an on-prem solution, and Zero Tier was my hero.
And Zero Tier was your hero, right?
Yeah,
and so Zero Tier is an overlay networking, right? And you just happen to deploy that in cloud, right?
And I do a little bit of Google Cloud because that's where I do all of my labbing,
right?
You know, so I'm familiar with their interfaces and stuff. But actually, I wanted to ask you before you dive into that, if maybe now's a good time, but should the on-prem network engineer, the traditional network engineer for the enterprise, also be your cloud networking engineer? Or does that need to be a different team or a different person or a different skill set? You know, like you said, there's 3 different primary clouds to choose from. So that's like 3 different vendors style of doing things. Is that something you just add on to your existing networking team? Or do you have a different set of people for that?
So it's a lot to ask, right? It's a lot to ask your traditional on-premises networking team to all of a sudden, if you're going to be in all 3 major clouds, and there's more than that, right? You get Oracle, Alibaba Cloud if you're in China. Like, I mean, there's lots of options out there for cloud environments, and it's a lot to ask depending on where and how many clouds you're in to learn these whole new environments, because they are wholly new. Like, what they're presenting to you is not traditional networking. You're not dealing with TCP/IP. You're not dealing with it's there, it's used, right? But you don't get to configure it at all. It's kind of just presented to you, and the things that are available to you are very black box. So like with your experience in cloud networking, Tony, like if you wanted to test bidirectional connectivity from a midpoint in the cloud to your host and then to your on-premise, like, do you have any device to do that? Right, like there's no way for you. Nope. Like if you're using AWS and you have Transit Gateway, like you can't just log into it, because I mean that's just a virtual router, right? It's a fancy virtual router that Amazon has developed for their purposes. They might be able to get onto it and ping and trace route from it because it's a Linux host under the covers, right? Like I'm sure that it's possible, but it's not exposed to you. You have no way to get in and get that kind of visibility. Until just recently, you could not get flow data from inside of clouds for applications talking to other applications within the same cloud, or applications talking between clouds. Like, unless you brought that traffic back to your on-premises data center, there was no way for you to know what the flow data looked like. I mean, these are really simple things that we're used to having in on-premises networks that just straight up don't exist in clouds because networking has been a second-class citizen. It's always been about the application. It's always been about the host. Networking is just enough networking to get the things connected, right? Like that's all. It's that minimum amount of networking is what they provide. And so when you as a network engineer are being asked to like be able to troubleshoot or provide insight, like is something happening in the cloud that's causing degradation of traffic? I don't know. Should I call Amazon? Right? Like, like it's hard for you to get that data, right? And so with this, the same problem that same problem was the same thing we had in MPLS networks. Beyond that first hop, I couldn't really tell what was happening in the network. One of the things that first started happening when SD-WAN first hit the market is people were interested in it because they could hold their MPLS providers accountable for faults in the middle of the network, things that you wouldn't have visibility for and could never tell that was actually what was causing it. Now when I have an overlay, I can say end-to-end connectivity is awful. I can ping, I got clear connectivity to your POP, right, from each side, but somewhere in the middle, you're dropping traffic or you're causing latency or you're doing something because you had end-to-end visibility from one end to the other end, right? And you did that from every node on the network. And so like it's like I said, it is this software defined networking, but applied for cloud. So let's talk a bit about the solution. I'm gonna bring up a visual here of the lab that we've built.
I was hoping there'd be visuals.
Yes, yeah, we're not just doing this all just audio. That would be a little much. So let me pull this up. We'll put us both on the side, and I can zoom in on this, right? So this is a lab that we've built at WWT. Me and a coworker worked on this. This is Aviatrix, and so like this is a very typical kind of an example of what an enterprise network might look like. Down on the bottom, we've got a couple of data centers, got a couple of branches. They're connected via different methods. We have Equinix in this because we're using Equinix for Direct Connect and Express Route. I mean, that's super common. But Equinix isn't a necessary part of the solution. It's just one that, we see regularly. So it's part of this. And then the top, and I'm speaking about this broadly, and I know it's very small on screen. So if you're following along, know that it's small. I will zoom in on this so you can see more about what's going on, right? Is you've got AWS and you've got Azure. And so, and in each of these, I think that the topology is going to look fairly similar. If you've worked with AWS and you have more than just a couple of VPCs, chances are you're doing a transit VPC or you're doing a transit gateway. So you have kind of like this hub and spoke design where all of your VPCs are connected to a central hub of some kind. And then those central hubs route between each other. And that's a pretty standard cloud design methodology. And this is something that we'd follow with these overlay networks. But what Aviatrix does is Aviatrix gives you your own gateway. It's not Amazon's gateway. It's not Azure's gateway. It's not, anyone's gateway except for yours. You run it. It's basically just a virtual instance again under the hood, probably just Linux, right? But they're presenting to you a router that you can use to build an overlay network. Not just it's going to facilitate connectivity, to the cloud. So this is from your on-premises or co-location or, like an Equinix fabric, whatever, right? It's going to facilitate connectivity from that in. It's going to facilitate connection within one cloud. So whether you're talking about single cloud, single region, multi-region, multi-account. Sometimes people split accounts to kind of like separate different functions of their cloud environment. And sometimes getting those connected can have some challenges just around because it's easy to say, yeah, connect these two VPCs that are in the same account. But then when you have to go to third party, it's not impossible, but there's additional components to it. And then between clouds, right? So how do I establish connectivity? Like if I have a workload in AWS that needs to talk to something that lives in Azure, how do I do that without having to make it come back and run through my on-premises data center? Because I think that's most people's traditional model, or come back and run through Equinix. How do I connect all of this? And so what this does, right, is it's like all things that are, software defined. There's a controller. So on our map here, we have our Aviatrix controller, and they have another service called Copilot. These are the two things, but really the controller is the key thing. The controller is what runs it all. It lives in the cloud, and then you have the concept of these gateways, right? And every little orange circle here is an Aviatrix gateway. It just sits inside of a VPC. Now, what happens is obviously Aviatrix is using those native constructs to establish all these things. It's establishing peering between VPCs. It's establishing, obviously, overlay networking between these things is doing on its own, but it's using native constructs. It's using things like security groups in AWS. It's using all those native constructs under the hood to get the connectivity established. But to you as the end person, you say, hey, deploy a gateway here, deploy a transit gateway here. Now, that's an unfortunate naming because Aviatrix named their transit gateway, which AWS also named their transit gateway. So have that conversation with a customer where every time you say transit gateway, it has to be the Aviatrix transit gateway and the AWS transit gateway. It's a mouthful. But regardless, you have this transit gateway, which again, if I zoom out here, lives kind of as a hub for a region. So as we look at this, and zoom in here, we're talking about here's US West 1 as a region. We've got 3 unique VPCs. They're each Let's actually look at the East because the West is a bad example. I'll tell you why it's a bad example in a minute. We have 3 separate VPCs in the East. They all have a gateway, at least one gateway in them. All those gateways connect back to this transit VPC. So if these VPCs want to talk to each other, it's just down to the transit and then back up to whatever the destination is. Right. And so you're building this connectivity model and a way to connect things in there. But if you zoom out a little bit and you say, OK, I want to talk between something that's in this, in this segment up here in the East over to Azure in the West, you look at the way the model's set up. I can set up connectivity that comes down to our transit gateway here that goes over to Azure over the internet. Like it's just an IPsec VPN type connectivity that gets established. It's not VPN, right? It's IPsec connectivity between all these devices, just like SD-WAN. So that's why I like using this example, because those who use SD-WAN are familiar with this approach to doing network. Create tunnels between everything, and not really between everything. It's really create tunnels between all of the hub locations. It's a full mesh between hubs, and then each hub is hub and spoke to all of the VPCs or VNets that it controls. So it's not a dramatic new infrastructure, but what does it give you? Right? When I start getting away from those native constructs, every place I have a gateway is now a place for visibility, right? So all traffic that goes through it, I can see flow data on it. I can do analysis on it. I can dig in and make sure that, I have reachability between things. There's some cool tools inside of Aviatrix that will let you kind of analyze the entire path. It's called flight control. So I can say, I want to go from host A to host C. They're in 2 different clouds. It's going to look at all the security groups. It's going to look at the segmentation you have set up. It's going to look at all the routing and make sure that you actually have a path. And if you don't, it will tell you where it's falling apart, right? So like in these complex cloud environments where if I was doing that between AWS and Azure natively, I would have to look at all of the security groups in AWS. I'd have to look at my routing out of AWS into my on-premises data center. I'd have to look at from my on-premises data center to Azure, and then I have to look at all the native routing in Azure and then the security groups in Azure. Like it's like 6 different places I have to check to make sure that that flow works the way that I want it to, so those 2 things can talk, right? When you do this overlay, obviously, because it's all part of the same network and you're abstracting the underlay, you get that real consistent experience. And so so when we look at this, like from a value position, right? Like you're able now to abstract away the underlay, and it's not magic, right? Every abstraction has considerations, but with that, you don't have to get really complicated in your networking in the underlay, because just like all these underlay solutions, right? Like it's all just about connectivity. So long as I have connectivity in the underlay, and using those native constructs, and again, it does it for you. I don't have to worry about that so much. So long as I've got solid connectivity there, then in the overlay, I can build my complexity. Right. And
so I think so far, one of the things you keep mentioning is like the native constructs, and the native constructs, just so I can echo it back to make sure I understand properly. That's just the way a particular vendor does something. Right. So the way AWS provides network connectivity versus the way Azure provides network connectivity to a VM or a host or an endpoint or whatever it is out to there. So is this vendor you said is Alkira or Aviatrix?
This is Aviatrix.
An example of Aviatrix. So does Aviatrix actually plug into those vendor APIs and drives the configuration of that underlay?
Yes, absolutely.
For like in your example, it's AWS and Azure. So it plugs in to the native APIs for each vendor and helps to control that initial configuration of the underlay.
Yes, absolutely. So it is plugging into those native abilities to build networks. So let's talk about AWS, because I think it's probably the most predominant cloud, although that's slowly changing, right? The way you connect, right? So let's just say you have 3 VPCs, since we're looking here. If I wanted all of these to talk without a transit gateway, I would have to peer each to each. So at 3 VPCs, it's not a big deal, right? I have 3 peerings that I have to build. A to B, B to C, C to A, right? Like, and we've built that. What happens when you have 50, right? Like all of a sudden for a full mesh, which is what you need for routing to work in that type of environment, you need to peer them all, right? And so there's a scaling problem. So AWS introduced Transit Gateway. Transit Gateway is a great tool. It's a native way to peer networking. And that creates very much kind of a similar model to and Tony, if you see questions or anything in chat, let me know, because I'm not looking at chat because my screen's up. But like the native model of Transit Gateway is a good model. It's relatively new for Amazon, just a few years old. It's not, it took a while for Transit Gateway to exist. Now I can peer everything with the Transit Gateway and it will have transitive routing. So I can go through it to get to other things, which is great. But then what happens when I need to connect to another region because a Transit Gateway lives within a region? Now I have to deploy another Transit Gateway, right? So like all these things are tools for connectivity, but that's just AWS. When you try to do that in Azure, right? Azure doesn't have Transit Gateway, right? They have a completely different model of connectivity. And so, like it doesn't have to be super confusing, but it can definitely get confusing, especially if someone who isn't familiar with the environment has to go troubleshoot it, right? And so you are correct. What these tools are doing is they're going in underneath and using those native connectivity constructs, VPC peering, primarily to connect all of these VPCs to your transit VPC and the Aviatrix Transit Gateway that lives within it, right? Like that's really where ultimately where you want to get that traffic going. But that VPC peering is only about connecting the routers, connecting these virtual gateways, because your host is sending the traffic to the gateway and the gateway is then putting it in the overlay. And now you're talking about going from the edge VPC, right? In that edge gateway to the transit gateway to whatever other edge gateway you need to get to in the overlay. So it's not using any of those underlay constructs to get from end to end. It's just using the underlay, of course, to create the overlay. Now, when you deploy this, you don't have to do any of that peering. Like you don't have to do any of the underlay peering. That's all done for you. So yeah, so we get visibility. I think we were talking there, like that traffic goes through it. We get those tools I talked about from any place in this network where you see an orange router, right? I can run those simple tools that we're used to having, ping, traceroute, MTR, DNS lookups, those other types of things from the perspective of the VPC, right? Because sometimes you can do that from the host, that's good, but sometimes the host isn't where the problem is happening. So being able to see, like, if I go from this gateway to this gateway, am I having connectivity loss? Am I having some sort of issue going on? Like, what's happening between these? And being able to get those both in an automated fashion, but then also to be able to do active troubleshooting is something you just don't have access to in the native construct. So it's there's value there in this particular tool. And then you stack on other things like segmentation. So you can build segments. You see, we have two segments here, dev and prod as an example. These are two completely different. We want them isolated. We don't want them talking to each other at all. What happens when I have dev and prod in AWS and dev and prod in Azure? Like, how do you maintain segmentation from one cloud to another? Most likely through your on-premises data center, right? It's either going to be a lot of VRFs. It's going to be a lot of funky routing. It's going to be a lot of different accounts. I mean, there's probably ways to do it, but it's going to add
the problem now.
Right. Yeah. Like you understand, like all of a sudden now, because we have a fabric, I have a firewall. It's not a fancy firewall. It's like an L4 firewall, but I can, like a firewall that's built into the fabric where I can say who can talk to who, regardless of where that app lives, right? It doesn't matter whether the application lives in AWS, Azure, GCP. You set up your firewall rules and say this application can only talk to whatever. Or you can set up whole segments that like don't talk to each other unless you allow that to happen. And then if you need additional firewalling, there's features in here that allow you to service chain to bring a firewall in. You can place the firewall, like we have a shared services VPC here with a firewall in it. So we can take traffic from up in our dev environment and say it has to hit a next gen firewall. And that's the next place that it goes, and then it continues on its way if it makes it through the firewall. And so, like being able to do this and do it consistently, and for that service chaining, it doesn't have to be in the same cloud. It may not be a good example or a model, but you could have that firewall live in AWS and send traffic that's from one VNet to another VNet in Azure, and send that to AWS for the firewall filtering if you want to. Again, not super efficient, but like it's possible.
So there's a couple of comments here, starting with Laz. Does something like Azure VNet Hub design do the same?
It's similar.
Is that question?
Yeah. So VNet Hub has a bunch of design considerations around it, and of course, it doesn't do anything cross cloud. So it will do it within Azure. But it's not going to do it, obviously, between Azure and, other cloud providers.
And another one from Spleen's Rule, using AWS Transit Gateway for 30 plus VPCs, and then having a VPN from Azure Virtual Network Gateway, Transit VNet to the AWS Transit Gateway works okay for us so far.
Okay.
That just sounds like a lot to manage, and it's a mouthful.
But it's completely that this is a great example. So that's a great example of, yes, you can establish connectivity, but what about visibility? How are you getting flow data from that? How are you able to troubleshoot that with tools within the cloud, not just from on-premises and into the cloud? Can you maintain segmentation with that? Can you service chain with that? Right. And so absolutely. Establishing connectivity that way, that works. You can establish cloud-to-cloud connectivity without coming on premises. That's not what I was saying. What I'm saying is typically it is, because each team is managing their cloud, and then it comes back via either a direct connect or express route. This is a more advanced type of connectivity. It absolutely works. And it's not wildly different than what Aviatrix is doing, right? Because Aviatrix has their transit gateways, and they're connecting them via VPN to each other. The difference is that because it's a controller-based network with all these additional capabilities, we're able to maintain segmentation across that. We're able to enforce firewall rules across that. We're able to service chain across that. So we're able to get those software-defined networking capabilities that lay on top of this that really provide some additional value.
Yeah, and I think that's great, having those firewalls, is being able to do service chaining. I was going to say, we run into that problem a lot, where you have, your on-prem firewall or firewalls for all of your sites, wherever they are. Hopefully they're one vendor. All those are feeding one type of logs into a SIM or some sort of log aggregator, right? Mm-hmm. And then what do you do for all the cloud logs? They're in different formats. They don't match the same. So typically, what the answer to that is you throw a virtual firewall of whatever you're running on-prem up into the cloud and route through it, so that now you're having the same visibility, into your SOC or into your NOC, so you'll have that. So this is just tuned way up. This is solving the routing and reachability problem, but I think that's awesome, being able to put those firewalls in line, so to speak.
Right. Now, one of the things you think about, like these environments, we talk about it with SD-WAN. They're like, you're very rarely deploying into a greenfield environment. Like, how do you handle that phased in approach to get from A to B? I have none of this now. I'm interested. I want to implement it. I implement it in a small part of my network. How does that talk to the rest of the cloud? And so this is where, when I said this was a bad example, it's a bad example because we created this on purpose to show what that would look like, right? And so these two VPCs up here, we have a development VPC and a production VPC. These are paired with a transit gateway. They don't have Aviatrix gateways in there. They're just traditional cloud networking, the things that we would do for typical connectivity. And what you can do is you can peer that transit gateway into the fabric. Now, obviously, when you have the gateway and the VPC, you get more visibility. You get those tools at the edge. So this is not the ideal setup, but the idea of like, how do you get from A to B? Like, you can pair with those native constructs. And if we come over to Azure, we have one VNet here that does not have a gateway in here, and it's just using traditional VNet peering to get in here, and we bring that route in and onboard it onto the network in the transit VNet and on these gateways. And so like, it is possible like to have, some or all of it all in there. And I think the last piece, and this is one that's really interesting, is a performance piece. So I deal with like a lot of Fortune 100 companies, people with high bandwidth needs. Transit Gateway has a limit for VPN connections of 1.25 gigabits per second. That's the maximum throughput you're going to get out of a connection. And so obviously there are ways to horizontally scale that up, but you're adding routing complexity and things like that. So Aviatrix has what they call high performance encryption. It uses a technology they call MeshNet or something similar to that. Essentially what it is it will give you a high performance encryption between two gateways. And so if you need more than that 1.25 gigabits per second, and Aviatrix will claim up to 75 gigabits per second, but like all security claims, Yes. Like all security claims, you need to know what the composition of that traffic really is, right? If it's lots of small packets, it's going to behave very differently than if it's lots of large packets. But being able to scale that up. So it's not uncommon at all for our customers have, 10 gigabit per second connections into the cloud. I have one customer that's doing a lot. They build automated cars, right? They're doing autonomous driving vehicles, and they're doing a lot of data processing. They are stepping up to 100 gigabit per second into the cloud. Obviously, this wouldn't meet that need just yet for 100 gigabits per second, but Aviatrix claim is 75 gigabits per second. When you dig into their documentation, they'll give you more accurate, how much actual speed you can get, but it's not unrealistic to get like 50 or 60 gigabits per second between nodes, which is just completely not possible with the native routing construct. So also then from a throughput perspective, there's some value here. Now, we've been talking a lot about Aviatrix, right? Like just because they're a great example, they're probably the most mature products on the market when it comes to this overlay style technology. Alkira works in a very similar way. Volterra works in a very similar way. I mean, again, we're talking about like the emergence of SD-WAN vendors. Like they're going to have some nuances and difference between the way they work. Alkira is actually an as-a-service offering. So the way that Alkira works, if we just were to back out just to kind of give you an idea, we see 3 layers. In fact, they're labeled over here. We have the application layer, we have the transit layer, and then we have the access layer. And so with this, the application layers is yours. You build it like that. You build your VPCs and VNets. The access layer is yours, right? You're going to be responsible for your on-premises stuff. You're going to be responsible for, getting, if you have Equinix or whatever for the connectivity in or the private connectivity. What they own is this transit layer. So where we see these boxes that have these transit VPCs and transit VNets, that's actually what they do. They call it a CXP. It lives within their own cloud environments, which right now exists in AWS and Azure, and you peer your stuff with their environment. And they act as that in the middle as a service offering. It's like the easy button for cloud connectivity for sure. But just like other places where it's an as a service or a very prescriptive model, it's going to have its limitations of what you can and can't do, right? Like with Aviatrix, I can put a gateway anywhere. I can connect just about anything. It does native routing. I could do BGP peering. So like I can even do funny things with this around, connectivity if I wanted to do it. With Alkira's model, because it's as a service, it's more prescriptive. I connect VPCs and VNets to their environment. I connect my on-premises stuff, whether it's IPsec, whether it's a direct connect or whatever into their environment. And it marries the two together and provides service chaining and segmentation and all these other things that you get out of this environment just as a service model. And so it's really interesting. I really just wanted to talk about it to bring it up as not a whole lot of people know that this stuff exists. And so in talking about that it's there, the other thing is, both solutions are relatively easy to deploy. I'm always hesitant to say that because everyone says their stuff is easy to deploy, right? But like the Aviatrix controller is available in the marketplace. You can just go in AWS and Azure or whatever, deploy it and start deploying gateways. They have a pay-as-you-go model, meaning that if you want to try it out without really dealing with them at all, you can do that. Obviously, you're going to pay whatever the rate is for the gateway to be deployed. You'd have to pay for it, but you don't have to go get quotes and deal with sales reps and all of that. You could go check this out kind of independently. And then if you decide to go that way, it would definitely advantageous to go talk to them to get, some sort of enterprise licensing agreement if you're going to be doing it at scale, because the pay as you go is just kind of meant as a ease of use rather than a long-term play. Alkira is a little bit, go ahead.
So I have a question, which is, I think this is a great example that shows inter-cloud traffic routing and availability. But is there any answer to bringing traffic to the cloud? Meaning, do they offer like a direct routing solution, an on-prem router, something to put there? Or is it just, hey, leverage the internet or your local, AWS Direct Connect, and just get traffic to the cloud?
So they both have IPsec connectivity options, right? So you can connect a branch or a data center via IPsec to them. Aviatrix has one hardware piece of equipment in their entire repertoire. And that is if you want to run high performance encryption down into your data center via direct connect or other connectivity method, they have a hardware appliance that you can buy and put in your data center to connect between that and the transit VPC or the transit gateways, Aviatrix transit gateways that are virtual and in the cloud, right? So if you wanted to get that, 50, 60, 75 gigabits per second capability from on-prem to the cloud while being encrypted, they do offer a hardware appliance to do that. Alkira does not. So with them, it's just going to be straight IPsec or direct connect. Now, I do want to bring up something that's interesting on the whole model here. Let me zoom out a bit. Everything north of this blue box, I build with Terraform. So it's all dynamic. So the only thing we keep live in the cloud environment are the controllers. And the only reason why we do that is because we like to keep the data. So this is a demo environment that's meant for customers, right? And so like if we were to rebuild Copilot and the controller every single time, it would be like a blank slate and nothing would be there. By leaving the controllers in there, at least I have the data from the last time I built the lab, because of the fact that this whole thing is disposable and I can just blow it away. We do, right, to save ourselves on cost. This particular lab is actually rather expensive in cloud. It's like $100 a day or something like that, like because of these gateways, because of the fact they're doing high performance encryption. We have larger instances in some of these places. We don't want to have that running if we're not using it, right? So we shut it down when we don't need it. And then I go and I run Terraform apply on my script and it goes and deploys. It takes about an hour and a half. And I'll tell you the longest pole in the tent is the transit gateway, the AWS transit gateway. That's what takes the longest to build. But it's not just AWS. I'm also building my direct connectivity. So I'm using Equinix's Terraform provider to build the connectivity in and exchanging like IDs and port numbers and things like that between the two so that when they build it, it's all dynamic. And so, being able to do all of this with that cloud native approach and doing it through Terraform and automation is really, it's really nice as well.
I think that's the coolest part of the whole thing.
That's why I say to the end.
Really, you should have jumped into the
Terraform and show everybody.
Yeah. No, that's very cool. No, I think this is super cool. This is something that hasn't come across my plate. I have very minimal experience in cloud networking thus far. I help out when I'm needed at best. I don't work with a lot of apps people. I wonder if is that a heavy apps driven world? I mean, do people who do cloud networking, are they working for companies and enterprises who deploy and manage applications and develop applications in the cloud? That's not what we do. So it's something that, we use the cloud as like, if it doesn't fit in our on-prem data center, we'll do it up there. Or if we have a specific demo or something we need to do. So it's not a lot of cloud networking I have to deal with.
So I'm reading through reading through all the chat now. It looks like quite a few people were chatting.
We were going on about logs, the Epoch 2038 problem. Let's see what else. MAC address exhaustion.
Right. So
a lot of stuff.
Yeah. So it's like, that's a lot of value. It's like free real estate. So anyway, I mean, it's not, I don't say it's, it's for everybody, but I definitely think that there's a lot of enterprise teams out there looking at this and saying, how do we navigate this multi-cloud thing without just like, shooting ourselves in the foot by having all this complexity. And then you have the additional stuff that is like, hey, yeah, it'd be cool to have those tools. It'd be cool to have the visibility. The high performance encryption really speaks to some people, right? Being able to do that where the native cloud constructs can't. And so I think that it's definitely worth looking at. But I took a little bit more time on that than I thought I would. So
no, it was totally worth it. I think it was an awesome explanation, and I was able to follow. It's not something that I deal with regularly. I think it was awesome.
Oh, good deal. So hopefully somebody found value out of it.
Now I'll get to go to work and they'll be talking about multi-cloud connectivity, and I'll be like, all right.
I got it.
I learned about this last night.
Zero tier. Zero tier is the answer to everything, right?
That's right. It depends, but yes, it probably is.
It depends. except for, yeah, it definitely always is. All right, Tony, you ready?
I'm ready. Hit it. Hey everybody, this is Naked Hardware. This is the part of the show where I show you a piece of networking equipment and I put it out on the Network Collective Twitter account and you try to reply with the answer of what that piece of equipment could be without looking at the chassis, without looking at the label, without any identifiers. So last week I tweeted one out and this is it's not our first piece of wireless gear, but that's okay. But it is one of the few pieces of wireless gear that we have had on Naked Hardware, and I was happy to have it. This is one of the newer products. A lot of times we get a lot of that old antiquated stuff, and this is one that's fairly newer. So let's go ahead and pull up the screen. This was the image that was out last night. Not last night, last week. And we got a couple of good replies on this one. This was a fun one. I saw this was a decommissioned piece. And it was sitting on a desk at work, and someone said, like, here's an AP. It's we're decommissioning it. Do you want it? And I was like, oh yeah, I'll take it home. I'll use this for Naked Hardware. And then I realized I'll just take it apart here at the office and take a look at it. And it was very cool. So we all kind of like stood around and looked at it. And not many of us, especially me, I'm not a wireless person. I haven't seen the inside of an AP. So this was all new for me, and I thought it was very cool. So let's take a look at the guesses. Normally, my computer gets very laggy when I start pulling these photos up. So let's see what happens. All right. So the first in was Warcop, Cisco
right.
W.
Good for him.
Yeah, just wireless AP 561 dual N.
Well, good for him if he's right.
Yeah, I was going to say, that's a really good guess. Really good guess. Let's see what else we got. We have a couple more to go through. Preston has it on there as a Cisco WAP 551. I'm not sure what the difference between a 561 and a 551 are. And then the third here... That is a microtick router.
I think you're wrong. I'm going to say no.
I show all the guesses. I show all the guesses. Right or wrong, I show all the guesses. This is your time to shine.
It was Benedict, right? Good job, Benedict.
Yeah.
Nice try. Thanks for playing.
And then lastly was looks like Ray Hendricks agreed, and he posted a link to the FCC ID. Looks like one of their websites. And for WAP 561, which has the inside look of the device.
So did somebody take your picture and do like a reverse image search and come across that?
I don't know. I didn't ask, but I was just thinking that's kind of like cheating, I think, a little bit. So, but anyhow, he didn't provide a guess. He was just co-signing what Josh had answered. So Ray isn't going to get a yes or no, but he does get on the board. All right, so let's take a look at the
He gets credit for some research is what he gets. Yeah.
All right, let's take a look at this one. This was a drum roll, please.
Oh, there you go. You're ready.
All right.
561.
561, everybody. 561.
So what's the difference with a 551? Because Preston guessed 551, and I want to make sure he gets credit.
Straight. I don't know.
Now Josh was first, so winner is there. He got both the model and the first guess, right?
Yeah. So this is wireless N dual radio. So and he even called out that it was a dual N in his post.
Okay. So
I wouldn't expect anything less. All right, but I also took some extra pictures. So while that chat is catching up, hopefully maybe Preston, maybe he knows the difference. Maybe someone knows the difference in chat. I'll scroll through some of the extra pictures I took of this. Again, this was my first like really close hands-on look at the inside of an AP. I thought the formation of the antennas here along the side were very cool. I'm sure that there's sort of a a engineering design on why they are cut and sized the way they are out of the metal. And I hope someone can drop me a good Twitter thread or something, or some good links either in the Network Collective Slack or on Twitter on where I can find more information about why are they designed that way. But anyhow, this is the underside of the board, so a lot of components there as well. Going through, I got a couple of close-up shots of the antennas. I just thought that they were sort of very unique, and I've seen any like it before. So, so there you go. Scrolling right through. Yeah, I took a bunch of pictures, and then I put the unit back together and put it back on the decom table. That's a close-up picture of the antennas there. So again, uniquely designed. Sure, there's a format. There's a reason it's that way, not just for looks, obviously, because no one's going to see it. So, so I kind of want to know why they are shaped that way. Here's a picture of the two radios, right? These are the actual radios. So I don't know if this is upgradable, meaning I don't know if you can upgrade this or if you can just replace the radios. So someone would have to set me straight if it's upgradable beyond N, whatever they're running, or if they're just replacement, if they can just be replaced. And then I think last picture there is just the faceplate. Oh, okay. Preston is he's catching up in chat with the live feed. Tony, they absolutely are designed that way for a good reason. I could probably talk at length about some of the considerations that go into it. The bend is for polarization. Okay, so you know what? We're going to have Preston on one day to tell us all about antenna design. Wireless AP antenna design. I think that sounds like a good use of our time. All right, so I think with that, I think we have one winner. Josh was the winner. Preston came in very close second, off by a model number, but because Josh got it correct, we're not going to play horseshoe rules. And it is not a microtick router, so that's all we got. Josh, I'll be reaching out to you to be a winner. And I did pre-schedule the Naked Hardware for tonight to go out at 10, so it is already out there on the Twitter feed, but I'll give anyone who's watching the live stream a little preview here. This was a donated one, so again, thank you for everyone who has donated. This is a Naked Hardware, a network appliance from, that's all I will say.
No more
but it was,
data. Yeah.
But it was from a community member, so thank you for donating and donating the images. And it's already out there, so if anyone knows the answer to this, what this is, go ahead and see it, Collective PC, Network Collective's Twitter, and make sure you reply with the hashtag Naked Hardware.
So there you go.
Yep, very awesome.
All right. Well, I think that wraps up another show, man.
Awesome.
Yeah, not bad for winging it. Had not having a plan.
Wait. Let's see.
Hold on.
Let's see.
How hot is Tony?
What's the temperature right now? Okay, just the wall. 89.2 degrees.
Oh, you're getting cozy in there. It's
Let's see my laptop. Jeez, look at that.
Yeah, it's because you actually made it do something. You opened a picture.
95.3. There you go.
Oh, temperature's rising,
I did
Tony.
I did a full 2 hours. Just I'm at a standing desk in a workshop where it's 95 degrees, 100% humidity because it's like it's storming outside, and my beer's hot now. So.
I'm just glad because it's storming here, or it's threatening to storm here as well, and I'm just happy that we didn't, get completely cut off because my internet service provider falls down when somebody sneezes. So, yeah, so we made it. All right.
We made it.
This is a good place to wrap it up.
And my laptop made it. So
yeah, that's good. It was struggling there when you were loading the pictures. You went all robot-y for a minute, but we've come to know that is to be expected. So guys, everyone who's watching, thanks for watching. Thanks for the chat. There was a lot of back and forth on chat today, so that was great, and do appreciate that. We will most likely be back next week, kind of just playing it by ear and doing it when it makes sense. So if you're in the Slack, pay attention to the Slack. We try to post when we know for sure we're going. We also post on social media. So if you're not following us on Twitter, @NetCollectivePC is where you need to go. That's going to be where we say yay or nay for a stream next week. I think that's it. I think we can wrap it up here. So Tony, it's been a blast, like
Absolutely
always.
Pleasure. Thank you.
And we'll talk with you all soon. See you guys later.